calculate the molarity of a 250 milliliter saline solution containing 30 grams of sodium chloride. So in this case, we're going to have 250 milliliters is going to be our total solution volume, and we're going to put 30 grams of sodium chloride in that solution. And so what you do in this case is just you write down what's given, and it's 30 grams of sodium chloride in 250 milliliters of solution. Now that is a concentration, 30 grams in 250 milliliters of solution, but that's not a common unit. So we don't normally do grams per milliliter. Well, we do sometimes, but in this case we do want to do it in the molarity units, which is moles per liter. So this just becomes, again, another dimensional analysis problem where you're converting. In this case, in the numerator, we're going to convert from grams to moles, because we have to get to moles per liter of solution. So we're going to convert from grams to moles on top, and on bottom we're going to convert from milliliters to liters. And for any time you have a chemical compound and you're given mass and you want to convert to moles, remember you just need the molar mass as a conversion factor. So in this case, we can convert the grams of sodium chloride to moles of sodium chloride using the molar mass, which you can get from the periodic table by adding the mass of molar mass of sodium plus the molar mass of chlorine, and it is 58.5 grams of sodium chloride for every 1 mole of sodium chloride. That's the molar mass. Okay, and then if we need to convert the volume to milliliters, to liters from milliliters, you just use the definition, the metric system definition, that there are 1,000 milliliters in 1 liter, or you could say 1 milliliter equals 1 times 10 to the minus third liters. It doesn't matter, however your brain works. And then you just do the math, because the milliliter of solution unit is going to cancel. You're left in units of liters of solution, and your gram of solute is going to cancel. You're left in units of moles per liter. So it's just 30 divided by 250 divided by 58.5 times 1,000, and that equals a 2 molar solution. Okay, as well. Oh, that's looking at them. A 2 molar solution. Okay. Here's another one. How many grams of silver nitrate must be dissolved to prepare 500 milliliters of a 0.15 molar silver nitrate solution? So in this case, we know what we want to end up with, a 0.15 molar solution, and we want to know how much of the silver nitrate do we have to weigh out and dissolve in the 500 milliliters, similar to the picture on the previous page. And so in this case, we're going to be using the concentration as a conversion factor from volume to moles to figure out how many moles that we need to put in and then convert to grams. All right, so in this case, what's given is the 500 milliliters of solution, okay? And what's wanted is how many grams of the silver nitrate does it take to make that solution be 1.50 molar, okay? And so in this case, the conversion is going to be from milliliters of solution to grams of silver nitrate. So if you start with what's given, 500 milliliters of the silver nitrate solution, that's the solution, and you want to convert and figure out, okay, if I have a 0.150 molar, then how many grams would be in that 500 milliliters, or how many moles would be in that 500 milliliters, and then I can figure out how many grams I need to put in there to get that concentration. So then you just need to get that into units of liters, because this is moles per liter. So that's going to be 1 liter divided by 1,000 milliliters of solution. Okay, so that's going to cancel. I'm left in liters, and now I can multiply that by the concentration, 0.150 moles sodium nitrate per 1 liter of solution. That's going to cancel. Now I'm in units of moles. Now I just need to get the number of grams,